for now. But welcome everybody. Joan, who just walked out, is the program director for the AA. We should have said thank you as she's walking out, but if you guys get a chance to say thanks, this is the AA Chicago space, so it's really great to have them provide the space. Yeah, and to allow us to have this as a regular meeting coming up in the next few months. So let me see if I can get this going here at the same time as we're talking. I wanted to just kind of introduce the group. Chicago Computation Group is kind of a new group that we're trying to form that is a resurgence of a group that one of the members, Keith Besserud, had started several years ago, and it really kind of fizzled, not because of the interest, or the lack of interest. I think it was more just because everybody got really busy, and then we got really bored in 2008. So we're trying to kind of bring it back and try to engage the larger community, because I think that at least a lot of people that I've had the chance to work with, work here, that there's really kind of a great community and within Chicago design community, but that includes architects, engineers, consultants, et cetera. And I think that that's a great opportunity for us to have a dialogue and exchange and really kind of throw ideas around with each other, because I think that this goes on. As we noticed when we were all standing outside, it's a big group of people that have around, grab some beers and have a good conversation. So let me see here. It's real. So tonight, I just wanted to talk about a couple things. We'll just, I think, keep it pretty short. It'll be maybe 35 minutes of presentation. Really, we're going to talk about the who, what, and why, and who is going to be just an introduction of the group and the core members, most people are here, and the what, I think, what we really want to accomplish with this group, and how we see it fitting in with the larger community within Chicago, and in with aspirations to take over the world. So who we are? We are computation.com. I think most everybody who's here got the email blast, obviously, and this is the website that we're setting up. You can go there and there's a form to fill out. It's really easy to say what your interests are and to have a good way of letting the group of us know kind of what ideas for programming or to stay in touch. I think we'll have regular programs, like I said, once a month, definitely starting with some good presentations in 2014. So, and we also have a Twitter account, computation, and we just set up a Google Plus page because the idea is that these dialogues and these presentations that we have will be recorded, and hopefully you'll be able to pull this down from the web if you don't make it. So this is just a screenshot of the website. Again, there's a form on the bottom. It will be a repository for both the presentations that we have and the dialogue that we have, and also I think a regular blog post by one of the core members. The core members in the group, there's 12 of us, and there's nothing strategic about that number. So if anybody wants to contribute, that's great. But the kind of great thing with 12 is that we are all kind of really interested in very different things, how computation can engage the design community and the design space that we work in. So you'll see people that are not necessarily from the design community. It's design with a big D. It can be engineers, it can be people, MEP engineers, structural engineers, architects, academics, and really we're trying to create a good set of dialogues internal. And then because there's 12 of us, we can very easily put it down the next 12 months to put together some really great programs. And I think that what we're going to do is kind of just walk quickly through each one of us that's here, and kind of just talk about basically who we are, what makes us kind of engaged in this topic, and that could be through the work that we do, or through the things that we're interested in. To me, that is kind of the nexus of what is possible with a group like this, is that we can through the different backgrounds and interests that we have, we can really put together a series of more panel discussions or dialogues that can engage the larger Chicago community, but really trying to show that it's not a single presentation of a single architect's work or a single consultant's work. It's really a kind of a team effort, and those teams can definitely be different experts within the field, or really highlighting the nitty-gritty of certain projects. So I'm Anthony Bottle, and my interests are how we engage buildings as hardware through our digital design space. So these are several projects that I've worked on, and these are all visual representations of what will hopefully be a physical thing. We use a lot of different tools at Smith Gordon-Gill, which are really tuned to try to understand, while working through design space, different analysis modes and different performance criteria to really deliver projects that are high performance design and really integrated approach. You can see these are just some shots of, as Jason described, my desktop. And through these projects and really having a mantra of firm being that form follows performance, we can really get into other hardware to do different custom and different analysis. So these are studies in the wind tunnel, which really help define as an iterative process, the process that we use to design. And that really, helped us design features within the building, which ultimately, saves embodied carbon. So what am I interested in? Beyond that, and this is some of this is kind of work as a firm, but it's also things that I believe that how I can engage the computation community, how the types of programs that I'll be putting together in 2014. So this is just sketches of how can we design interfaces that link hardware and software together to do very complex analysis of designs. And also linking that with the physical design space, which is shots of hardware tests and software. And when you link those two in a design space, you can basically do real-time analysis of metrics, criteria, performance criteria, solar criteria, energy criteria. Second person up is Keith. He's not here, but I can tell you that he's a director at Skidmore, Owings & Merrill, and he's the head of the Black Box Group, which is engaging in large, in a lot of projects. His particular interests are these kind of urban scale big data. So the types of programs that Keith would put together are, really have to do with different, computation groups that might be existing in Chicago already. So, data science for social good or computational.
I'm Matt Herman. I'm with Apple. Do you want to try?
Yeah, let me try to this.
So, what I do is I get the opportunity to work with a bunch of great architects, engineers, and other consultants to deliver fantastic built environments. What I'm interested in within that context is this idea of leadership in a changing industry. What I mean by that is the reason I'm involved with this group is I want Chicago as a group, as an industry, to lead that forward. And there's amazing architects and engineers here. And putting them together, the right team, and giving them a forum like this to drive ideas forward, I think is critical to the success of all of our practices. I also teach at IIT, and one of the, at IIT, every year, about the end of the summer, I have a sense of dread that ultimately falls on me. I'm like, oh, why do I do this? It's so much work and effort. I really don't have time. But the reason is because all those young students represent so much opportunity, and they have so much drive, and they're ultimately going to be the implement of change. So linking them to this group, I think, is important. Reaching out to other schools, there'll be some other people talking about that, is incredibly important, because they're going to be they're looking to us for leadership now, but in 5 to 10 years, they're going to be in these seats. I think that's really important for us all to recognize and engage in some way. Next slide. So this is kind of the best diagram I saw for what I'm interested in, both in terms of academic but also profession. When I'm approached with students, I kind of feel that they're at one level that they're very simple. They understand very small components of different things, right? Well, I know that I can build a BIM model or a SketchUp model, or they understand kind of that there's glass and there's some stuff. So they have a very simplistic view of design. But reality is that design's always this incredibly jumbled mess. So you keep on adding information to them, and they do a pretty good job sorting it out. The problem is when you get it in the industry, it's actually the reverse of this diagram. You have incredibly talented professionals who have a jumbled mess in their head of years of experience. And what you actually have to do is sort that out in order to drive very simple decisions. Computation is one of the mechanisms for doing that. And right now, I feel that we're at this kind of verge, similar to Keith's interest. A lot of the work that we're doing right now as a company is taking large amounts of data set that span across multiple states or nations and trying to make sense of it all so that we can write meaningful policy that ultimately trickles down to our day-to-day design decisions. So computation is a means to that level of change. But once people have good data, they make better decisions. It's that simple. Whether it's about a facade, a gasket, a material choice, or how to run a city. I think this is where I see Chicago leading the way through the work of Smith Gill, SOM, the recent legislation here in the city, and I want to be a part of that. That's it.
You want me to? That's okay. I'm Aloy. I work at Thornton Town Study in the building scheme group. Thornton Town Study is usually known for its long span and super tall buildings. But the building scheme group does different elements of structure, so glass or tensile membranes or CFD, things that are not your typical concrete and steel. So here's a picture of some glass. This is kind of, I open this program probably once a day to just analyze a piece of glass or a balustrade or a glass stair or something special. And then the next slide. Here's the project that we're working on that has UTFB. This has been really challenging because it has all these different people involved, the city of New York, the architect who is very picky, like SDS and Diller's video, and their demands, you know, and we have to keep up with them. So this is something where I use Grasshopper all the time. They're using it to update their model. I use it to get to pick up the panels I need. I map the RWDI load data on it to determine which panels are critical, and then just study that in order for us to get a response quickly. So what I'm interested in, computational wise, is kind of linking real data with models and getting quick feedback. And I like to see results quickly and be able to get feedback. For example, this video we did last year, we were analyzing the panels that were over the size limit for that material based on the snow roads in Moscow, where it's located. But something that we as a company have explored is trying to create a separate group for research and development, which includes Grasshopper stuff. And that's called the Advanced Computational Modeling Group. So maybe some of your firms have had visits from those people. They basically spend all of their time working in Grasshopper and linking programs. But beyond that, I guess, as a person on the ground who has a job sort of other than solely focused on Grasshopper and computation, this is basically what I use it for. A link with Excel, a visual output, be able to give an answer. We even send in Grasshopper models, and that was fully. And here's an example of just, this may seem really simplistic compared to, looking at an entire tower for Anthony. But I use grasshopper all the time to analyze a cable net wall before actually analyzing. So before it actually gets into, one of our structural analysis programs, we can produce a graphic that will show us panels that, already given the limitations of the supporting structure, may be at risk. And so then we can kind of tell our guys, hey, our structural guys, we may need to bump up their structure based on this very quick look before us even, knowing for sure engineering wise. So my interests are basically linking our engineering data with the visual, with the physical model, and creating a link to be able to feedback, and making custom tools that can do that quicker. And that's, like a cable net tool or voltage analysis tool. And also, there have been a lot of times where towers like, Smithfield does, where we'll map mullion locations onto an entire facade and want to know right away, will a certain depth it would work with a special tool that just quickly say, yes here, no in this area. So that's kind of where I'm interested.
All right. I'm David Lefevre. I work with Gensler. Prior to working with Gensler, I worked with Gill for a few years. So what I do, I guess I'm just saying, like, with this diagram, which is the diagram from the 60s, is from Charles and Ray Eames at an exhibition of their work. And I came across this recently in sort of trying to define what computation is at Gensler these days. This diagram is basically just a Venn diagram that represents the design office, the client, and society as a whole. And if you sort of take those three elements and break them down into the community, the client, and the design office, to contextualize that within Gensler, Gensler has a pretty wide range of scale projects, and a lot of it is in the Chicago office, where they serve a lot of developer-driven projects with kind of really ambitious schedules and low budgets, and trying to kind of expand the definition, at least in my own head, and then trying to kind of communicate with some other people, with Brent and Corey and Mike, trying to understand just what all computation can bring, what it can utilize to create interesting solutions. And so what I'm saying with this diagram is that computation basically allows all of these elements to change, to be dynamic, because we all know that community groups change, clients change, their interests change, their leadership changes, the design firms all kind of change really kind of aggressively. And in my mind, I'm making the argument that computation allows us to kind of manage that design space, those overlaps. And at Gensler, there's a couple of really interesting sort of possibilities. One is Gensler does a lot of interior projects, and I think that that's like a really, really kind of big opportunity for computation. And then also, which we're going to hear a lot more about probably in a few months, is the strategy and analytics group at Gensler. There's a pretty robust team of analytics guys and economists who work there. And what they try to do is, at the community level, they try to kind of imbue economic impact and feasibility studies into the projects. And I think that this is a really interesting potential sort of design space. And I don't necessarily know what the impacts are right now, but I think that at the building scale, at the community scale, there are kind of corporate headquarters projects where corporations these days just generate so much data. How can we sort of understand their data, find some interesting insights, and have those insights affect the design of some of our projects. So it's kind of a work in progress. Hopefully I'll have something a little less diagrammatic to show.
I'm Emir, and I'm one of the rare workers that get the chance and opportunity to do something creative while also doing work. And what I do starts with something really dumb, which is geometry. Geometry exists in the architect's head and the client's expectations. But the geometry I work with has much more information in it, and I'm not talking about BIM or Revit or the buzzwords. I can go to the next one. What I do with geometry is I embed so much technical information in it, such as this one, which is all connected, all these boxes represent one of the other zones or nodes in the model. And then I get the chance of modeling advanced mechanical systems in the geometry, which is informed by not by just the environmental factors, but also the way they are used. Right? But then that can also be visualized by each and every air particle, which is the screenshot of the computation fluid dynamics, which still is fed from the geometry, but goes way more beyond it. And then as one of the rare items in the built environment, computational fluid dynamics actually have the word computation in it, so it's pretty obvious. And that's right. I also get to do much of the daylighting stuff in the office, which I tend to approach differently, not just like leave daylight credit, but also inform the client, okay, here is some excess daylight coming in, and some of the mitigation strategies, how to deal with those. And how, in this case, I'm just pointing out how one small atrium can affect through the skylight all the deeper floor plates down below, and where it's bleeding of sunlight. But then there's also weird cases where clients are ready to dump so much money to naturally ventilate their offices. And then that's where we get so creative about trying to analyze the possible hours of ventilation, and then through a couple of double skin facades, trying to increase that band of the possible natural ventilation hours through the protection of the cavity, and then therefore heating it up, and then therefore expanding the number of hours and computing where they occur throughout the year. This is just 24 hours per 365 days graph, and I can definitely see here where it would be comfortable if I open the window in a double steam facade and natural ventilated space. And it's really not very tied to what I'm interested in. Does anybody know what these are? I don't know quite as well, but it's about the fundamentals of optics and how human eye perceives some of the things. It plays a role when we are computing glare, which is a function of vertical illuminance versus contrast ratio. However, it gets much deeper than that when you dig down into the very fundamental physics of how human eye perceives in the everyday life. Next slide. And what I'm trying to learn on my own is how it all plays down, how that can be studied in scientific departments other than architecture firms, and how the very photons of the light diffuse, or how they behave through different materials and mediums and through different spectrums. And it's a very deep dive, and I'm not there yet. And that's where I draw on this. Thank you.
So, my name is Mario. So I'm kind of a weird mixture of different fields and amateurism. So I'm a student right now, but I started at Smithfield in the IT department, and I sort of crossed threshold between IT and architecture for 6.5 years. So the thing that I'm so that's me. The thing that I'm interested in is That's Jason. I'm interested in Jason. So the things that I'm interested in, at least at current, at least you is sort of like visual fabrication and utilizing robotics within architecture, and sort of driving, as like Anthony was mentioning, sort of an architecture as a machine, and so driving interactive sort of objects or interactive designed objects within architecture, and how sort of you can begin to manipulate the scale of that from sort of 1-to-1 to something as large as a skyscraper, and sort of what effects that play out. And so those two things are, like, they seem dichotomous, but in the things that I've been doing, looking at and researching, like, I'm trying to find a way to sort of melt the two, because through the use of visual fabrication, we can create these new designed objects that are both interactive and sort of effective with people. And so I guess that's it. I mean, like, it's, again, it's a mixture of different, because my background in IT and architecture, it's me trying to sort of meander my way through both these fields of technology, heavily based on computers, heavily based on sort of networking, these nodes that drive the things that we do now, and utilizing it and figuring out sort of what the future of that is. Now,
Cool. Can I go rogue for just a minute? Sure. Maybe intermission. Yeah. Cool. I feel like we're talking a lot at everyone here tonight, and I think that's really good because we're just trying to sort of, well, as is obvious, introduce ourselves and sort of say this is kind of what our interests and what we do. And that's important, but I think all of us, in a dozen or so of us that have met over the past 6 months or so, we're really hoping that we could expand a dialogue that was more than just us, and to introduce something to the city of Chicago that could be a collaboration, because we can only get so far on our own. And the idea that I'm an expert and I know all these things and I'm not going to tell everyone else because I'm afraid that they're going to steal my ideas or take my job, I don't think any of us buy into that. I think we all buy into the idea that we work better as almost a collective. We can feed off of each other and play off of each other. So I think in future meetings it'll be a lot less of us talking at all of you and more of a roundtable type discussion with panels or presentations, or even just, hey, I've been doing X, Y, Z, and I'm freaking stumped, so anyone got any ideas? And that's what the forum on the website, I think, is largely for as well. So, sorry if we were going to get to that.
Yeah, you're getting all the
So, yeah, my name is Jason Smith. I've worked at a handful of firms. I'm an architect and a designer, and this is a little bit of what I do. I like to get my hands in a little bit of everything. So I do things very early on as I'm developing the initial ideas for projects. We can see on the top there is me starting to look at how daylight influences potential conceptual masses. As the design moves on, I get into more of a development stage and into rationalizing geometry, verifying that some of the assumptions we made, maybe about daylighting, maybe about solar radiation, are working. On the bottom here, it's a little grasshopper doodle on building some sunshades that are rationalized based on feedback we're getting from manufacturers and installers, so that we can keep them in a project and also keep the visual of them. Sometimes you get in fights with those guys because they always like to tell me no. I like to say yes, I can. I generally try to find ways to do it. And then this is very detailed. For the last few months of my professional career, I've been heavily involved in actually pulling something out of the ground. And I've done a lot of this where I think sometimes people think that you have one model that holds your concept and your initial design, and then we transfer that to a different model that holds all the technical construction building information, and then you have whatever else happens after that, drawings, or emails or meetings, etc. But I actually use them all together all the time, and I just wanted to put something up there with respect. So what you're seeing is a little snippet of this, believe it or not, it's sort of a leaning post that's actually got few kinks in it, and it's a sort of helix shape. So I'm going back to my Rhino model and figuring out exactly how to rationalize that with sometimes computational tools, sometimes just the old-fashioned tools and figure it out. Bringing that into our construction model, and also from there going into how do we manage to communicate that with the guys in the field. I try to do that with the model as much as I can. I think that's really cool, but oftentimes, you have to go to performance. And this is my last slide. What I'm really interested in, especially at Smith Group lately, it's become apparent that we have this really strong connection with a very strong mechanical group and a very strong, I don't know, I guess an architecturally technical group that has all this insanely detailed information about how your mullions work and where condensation might form, how and where that might form. That's going to be a problem. And it's all sort of in this vacuum. And right now, the architect, have to be the one who goes in between those guys and everything else and make sure that what I wanted in the design comes through. But I'm sort of very interested in computational tools linking all of us together, not just in a way that is satisfactory to be the architect, but also that the mechanical engineer will say, actually, yeah, I buy it. I'll work with those assumptions that you're making. So, if we can get some very technical things like that, immediate feedback from those very early on, that's sort of where my main interest lies. Thanks.
Sure. I'm sorry to be late. I've been running all the past 2 months. I just had my final tenure review. I'm from the School of the Arts in Chicago. And if you ever have a chance of going through tenure, don't do it. Can I close this? Sure. And so I really like the discussion of amateurism. I think that's really very cool. I like being a little bit of a troublemaker, which is maybe why I'm at your institute. We don't think practice is all conventional, and we see that there's obviously like a great amount of change happening. And I don't just teach architecture, I teach painters who produce sculpture from trash. And I just like this. So this is what I was just talking about. So, but I'm not going to show this to you guys. So this is just a little bit of something that's occupying me at the moment. And I think that we have to be very careful. I'm in the field of education, but the way technology is moving, soon we all might be out of control. And so this is just a little experiment that I've produced to try and automate some of my own work and try to eliminate as much design as possible by building tools that do the design work for me. So I think that the dialogue is actually, it's all great to talk about advancement and energy and all of these things, but there are real social consequences to what we do as designers and how we operate as practitioners. And I see really that as the real heart of what this group does. Not to discount energy, that is absolutely central to some of the things that are driving changes that we all know about. So I've been investing a lot of time in automation, and I've been building software tools that this is applied to my work that can generalize to, any of your projects. That's something that I'm really very interested in, just to see how that plays out as an end game in architecture. But the real work that I do is, and I'm just going to show a video of that applied to kind of what I do, kinetic work. So I have a small office called the Office for Robotic Architecture, Media, and Bureau for Responsive Architecture. It's a long title, and it's a long story as to how it happened. But I'm very much interested in seeing how things like automated technologies can be placed into buildings directly and understanding them in very, very precise ways. And really that's, I guess, all I have to say. I think that the future is open to those who want to change it, and that everyone in this room should really work to do so.
Okay, last but not least. Back.
So I'm Brent Watanabe. I'm currently at Gensler. I spent but before that 5 years at Smith Gill. Working with this joker. That joker for a little bit. So a lot of what I did at Smith Gill was, parametric modeling, optimization, things like this. How can we get kind of complex, advanced facades onto a building quickly for competitions? And then there was one opportunity where we were able to explore a little bit evolutionary design using Galapagos and a grasshopper. So form optimization, trying to just mitigate solar gain on the building facades. And that kind of plays into, I guess, what I'm interested in, this idea of data visualization and Tristan's, movie images, data visualization, all these types of things that we can start to use to, everyone's talking about big data, like how can we actually start to utilize all this? And the first step is, of course, to visualize it, show it to the client, show it to the design team, and then from there start to actually implement the information and use it to affect change. Here's an example of was it the total carbon emissions per capita and the rate of change in sea level. Like all of this data wasn't possible before. All the visualization of the data wasn't possible until we started using these computational tools, and things like Anthony's what do you call it now? Design space. Tangible design, augmented reality, things like this are tools that we should start to be able to use to present to clients. Things like CFD information, not just looking at it in a planar view, but starting to look at it in 3 dimensions. Now, I'll be frank, I don't know how to do any of this yet, but this is something that I think that all of us, might show some interest in, and I think it's something that moving forward with this, as technology advances, things like this would become more accessible. So I think over the course of next year, we might try and tap into some of these guys who are here in Chicago to try and come in and talk about data visualization and how we can use that to affect the built environment.
Thanks, and Brent and Jason both bring up a very good point. And I'll just blast through this last 2 minutes, of more beers and good conversation. But I think what we want as a group is this idea that it's really a dialogue, so thought to engage some of these groups and to have those groups talking about ideas in the context of not just their work, but the context of the groups that they collaborate with is really a way to, again, enhance the dialogue. We want advocacy for design profession and what our value is within it, and how computation and performance and the environment are all part that equation. We want, an exchange, both of knowledge, ideas, thoughts, experiences, and methodology. And most importantly, we want a dialogue. We want to have this be the gathering of industry professionals, not only the whole design community, to really have meaningful dialogue and discussion. So why Chicago? I think that we touched on this as like Chicago being really kind of innovative and the heart of some of these groups that really just need to be tied together and create that dialogue. Why computation? It's more than just a t-shirt. There are big kind of initiatives within the city which are really great to tap into, especially with big data and the data portal with the city tracks, and how that can then have an effect on how we as the community and engage that design space. And then I just want to say again, thanks to Chicago for kind of allowing us to bring this group to this space. I think with that, if anybody has any questions or comments, but we can also have a more informal discussion, have some beers and